might also want to make some descriptive statistics. So here what I'll do is I'll again use group by, but I'll group it by the summary data that I had before. I'm going to make a summary where I make the mean of my log reaction time, a standard deviation of my log reaction time, and I'm going to get n, which is the length or how many participants took part in the study. So here I calculate this by getting I'll get all the unique participants and then get the length of that unique number. So that's how I get n. You should get an output that looks like this, where it says you've got English and other categories. Here's the means and standard deviations, and there's your n, how many observations go into that. So I had 13 people in the English condition and 10 in the other condition. So I'll return to this. I'll make my descriptive statistics. I'll make it below the density plot. So we'll call this make descriptives, and we'll say lexdec descriptive might do it. And we'll put in lexdec subjects. What do we do to that? We'll group it by subject. So we just want ones per, we're going to group it by native language. So we're going to aggregate over every subject within those native languages. We're going to make a summary. So summarize. And we're going to say mean RT is mean RT, or we'll make mean log RT. SD log RT is SD log RT. And n is length unique subject. And this should all run perfectly now. So if I now put the name of my variable at the bottom of this chunk, I should get this out. So that's my output here. Now again, this is in my file pool here, but I haven't saved it to, sorry, it's in my global environment, but it's not in my file pool for access. So I need to figure out how to save this. So how I would do this, I'll show you now. I think I come to this later on at the end of this presentation actually, but all I need to do is use the write CSV function instead. So I'll do write CSV, and it tells me what I need to do. So what's the name of the thing, and then what's the path of the thing here. So the name of the variable is lexdec desk. And the path is just going to be what you want to call the file, including any file path to go to subfolders that you need. So I'll just call it lexdec desk again. And I need to save that as a CSV because I'm using write CSV. So now what's going to happen is this is going to print out the output, and I can add in a comment here, which is write to file. Now this essentially won't be read by R, so it's just for my use. So if I now press play, it said it couldn't find ledec desk, so it's lexdec desk. So I made a problem there. So that's good. If you ever have errors, just double check that you've written things out properly. So there you go. I now have lexdec desk in my file pool, so I can download that later on. So we've done pretty much everything that we need to do now. The only thing really left to do is to fit a model to our data. So I'll just progress with these slides now. So we've made our summary. So we're grouping by native language and we're summarizing the data here. So we've got all descriptives that people might want to know. So that tells us about what our sample looks like. Now we want to fit a model. So I've already spent some time on how linear regression works in the previous lecture, but here I'm just going to talk about how you kind of go about doing that in R. So first off, we're going to take our data, lexdec subject, and we'll have that factor. We have this native language column. Now, right now, that's saved as a character. That's the data type. So it's a vector of characters. Now, what we need to do instead is we want to define this as a factor. So just assign it to itself as a factor. Now, what this means is we can use factors in the linear models in R. So it figures out that the numbers correspond to the levels for defining different conditions in an experiment. We can ask what the contrasts currently look like as well when we do this. So at present, if we assign this a factor, then the contrast should be 0 as English and 1 as other. Now remember, we want our intercept to be representative of the overall mean across conditions. Right now, if the intercept is the value of our outcome when our conditions are 0, then it means that the intercept should represent reaction times for the English condition only, while the slope will be the difference between English and other. So what we're going to do is we're going to change these contrasts. So we'll assign this as a factor first, and then we're going to change the contrast. So we'll use the contrast function on the column that we care about. We're going to assign it these concatenated values of -0.5 and 0.5. When we do this, our contrast should be the way we want them, so that the intercept is representative of the grand mean. So first off, we're going to take our data, LexDeck subjects, and we're going to change that column, native language, to be as.factor, LexDeck subjects, native language. Now we're going to do contrasts, and we'll just actually copy this out, so I don't need to type it out and maybe make a mistake. And we'll change this to -0.5 and 0.5. Now if I then look at my contrasts again, hopefully everything should have changed appropriately. So I'll do set contrasts. That's the name of this code chunk. So if I run this, now English is -0.5 and other is 0.5. Now what you could do is don't set this and actually see how your linear model turns out and see if you can recover what those values represent. It's probably a good learning experience for you. So R uses this model interface, this formula interface for defining your models. So how this works is it says I want to create log reaction time as a function of an intercept plus a slope, which is the slope effect of native language. So how does native language affect your outcome? So what we're basically saying is log reaction time is dependent on your grand mean plus the difference between the grand mean and the native language that you have. So if I'm English, I should have some adjustment of that grand mean to my to get the scores that I have. So the way we do this is we use the function LM, linear model. We'll set our outcome, the thing that we're trying to predict, and we use tilde to say it's a product of. We'll set 1 as our intercept, which is actually implicit in this formula, so you can leave that off, but I think it's a good way when you're first learning to see that it should be there. And a slope, which is native language. Within that, finally, you just say the data, where does it come from? LexDeck subjects here. And I've assigned this to LexDeck mod, okay? So we'll call this fit model, and we'll go LexDeck mod, and it's assigned from LM log RT is a function of 1 plus native language, and the data is equal to LexDeck subject. Now if I just print the output of this, what happens? I'll get the coefficients from the model. So you see that our intercept is 6.4095 and native language has a slope of 0.1218. Now where do these values come from? Well, the grand mean is pretty much equivalent to the average between these two. And if I take the difference between, let's say, 6.47 minus 6.35, we'll round up, then I get about 0.12, which is pretty much where the slope value comes from here. Now again, we already got the grand mean of our reaction times earlier, so you could have a go at doing that for the log reaction time to see that that's exactly what that intercept represents. So a nicer way to get all of the summary output from your model though is to use the summary function over LexDeck mod. So summary works differently on the different types of inputs you give it, but it's very useful when you're fitting data here. So instead of just getting the coefficients, I want to know, well, are these coefficients any different from 0, as I've already talked about in the previous lecture. So I press play here. I'll see that it gives me a description of what model did I fit, so you can double check your work. It tells me the residuals. This is the residual error in the model that I talked about here. These are what you should really be caring about and paying attention to, which is your coefficients. So your estimate here is what's the parameter estimate for the intercept. So it's about 6.41, so what we had before. what's the standard error for it? So remember I told you how that's calculated. It's how people deviate from this estimate given basically where they are on that line. And this is calculated in regards to how big the sample size is as well, which affects your t-value. So your t-value is saying how big is the effect that you have. Now this PR greater than t is essentially your p-value. What's the probability that you get this t-value or larger given that t distribution that you have, assuming no effect? So this basically says that an estimate of 6.4 is so widely different from an estimate of 0 that it's very significant. And this is what these significance codes highlight here. So it's practically 0, the p-value. Now native language were like, we don't care the grand mean. Nobody cares what the grand mean is here. What I care about is, do the two conditions differ? So here's my estimate. There's my standard error. My t-value is 1.99. So it's reasonably high, but maybe not high enough, it seems. So our p-value is 0.059. Now what that means is because that number is not less than 0.05, we cannot reject the null hypothesis in this case. So we failed to reject the null hypothesis, which means we failed to reject the hypothesis that there's no difference between the two groups. So now if I return to this output, this basically gives that full interpretation of what I've just talked you through there. So the intercept is the grand mean on that log scale, and the difference between conditions is again about 0.2122 on that log scale. Only the intercept is significantly different from 0, but we don't really care about that. All we care about is that difference on the slope, which is showing that difference between the two conditions. Now, unfortunately for us, if we cared about observing it in our study, this means that this effect is not surprising if we assume that there's no true effect in the population. So we can't scale up from the difference in our sample to say that there might be one in the population there. So then where do we get these scores from? I kind of already talked us through this when I was working in the console just before. So here's our mean scores, 6.35 and 6.47. And we'll see that these correspond to the difference between the two slopes. So if I take 6.35 and get the difference between 6.47, then it's 0.121, which corresponds to that slope output that I had before. I've already showed you how to write your descriptive statistics to your output data, but you also might want to save your model output. So we'll do the same thing with write CSV, but there's this nice package called Broom, which saves you doing a lot of things for processing your data. So you might have noticed that the presentation printed in this console is very different. It's not in a table here. So how are you going to print this in a tabular format? Well, what we can do is I'll install the Broom package. So I'll just type this in the console again. So install packages, Broom. I'll say no this time. It should work fine without me restarting R. But it's normally a good idea to, once you've done this, is to restart and go again. And I'll do, I'll save my model output and I'll call it tidied model output. Tidied like stack mod is Broom. So we'll use Broom tidy, the function tidy from the package Broom, and we'll take it from this. Now, when I write this to the console, so I had to do a special thing there. So did you notice that the tidy function didn't work? Now what this means is that there must be another package I have loaded, which I had first, which is called tidy. Or actually it could be the case that I forgot to actually load in this Broom package at the top. So I've installed it, but I didn't load it. So that's a very common error. So we'll do load in Broom. So when you reload this all again, it should all work. If I scroll back down, I use this basically this double notation here, which says I want this function specifically from the Broom package, and it searches and tries to use that even if you don't use the library function. But this again is a little bit advanced. If you've already called library, then all I need to do is I didn't do it again though, did I? So I'll do a library Broom, should be loaded up here, and now that should work. So it does here. So now it basically puts it in a table format. It says these are the estimates, there's the terms, there's the standard error and the stats and your p-value as well. So you know specifically that that is a p-value now. So we're going to save our model output. You probably don't want to have all these kind of extra decimal places when you're going to be writing things up. So you might want to round the numbers. So you can use this mutate if function. So what I'm saying is mutate every column, the contents of that column. If it is numeric, round it. And I'll add this additional argument of 3. So you're going to round it to 3 decimal places. So what this means though is that these p-values will be rounded up to 0 if they're essentially very small numbers. Now what we normally do in reports is we'll report them as p is less than 0.001 because essentially it's unlikely that a p-value is ever going to be exactly 0. It can't be, because we can't be certain that there's no probability that this is kind of came about due to chance. So what I'm going to do is I'm going to skip off that additional part there where we kind of round the numbers up. You can follow that from the slides if you want, but I'm going to write this to a file. So I'll do write CSV again, and I'll do it. What's the file that I want? Well, I want lexdeckmod, and I'm going to save it just as that.csv. So I can run that again, and you see that it pops up in my file list here. Now, the important bit is obviously we want to be accessing this. So all I need to do is click on anything in my file pool and tick off the things that I want. And I just need to click export. So I go to file and export in my file pane. So here what I might do is I might want to export my report. I might want to export my plot. I might want to export just the model, I'll say here. And I don't want any of the extra data. So I'll go to more, export, and I can download them all in one zip document. So I can save this. You see they're going to pop up in my downloads folder. Let's open this up in Finder. Look at my export. Do I have my graph? Hopefully I do. There you go, there's my box plot. So now you've got everything off from RStudio Cloud. If you were to do this just in regular R or RStudio on your desktop, then you obviously wouldn't need to be doing this export files thing. You just write them to CSV and it'll go straight to the folders on your computer, or save it as a PNG. So this is a really quick crash course in R. I know there's a lot to get through, and I obviously didn't have really time to explain how I'm making all the decisions I am making or how all the code works. But hopefully you've seen how quickly you can go from taking some quite messy data to tidying it up a little bit, to then making a documented notebook to talk about maybe why you would do this and how you might filter out and clean data and make summaries of that data. It's very easy to make plots in R using that ggplot package, and it's also really quite easy for you to make to model data directly in R as well. So I'd say though, if you want to learn the R syntax, specifically using this tidyverse family of functions, which makes everything really nice and readable using English verbs for things, then read R for Data Science by Hadley Wickham. So Hadley Wickham is one of the chief data scientists at RStudio who works on these tidyverse functions. As well, if you want to look at this from a psychological perspective, look at more my work, then you can use this R for Psych webpage, which is essentially a free webbook based on this R for Data Science, where I talk about everything from the very basics. So looking at data visualization, manipulation, simple statistical tests, all the way up to how to simulate data and doing advanced multi-level hierarchical modeling. So that's pretty much everything. One thing you might want to do with your model is to check how well it fits those assumptions of the tests. And all you need to do is use the function plot over the model name that you have. And we can select individual plots that come out of it. Here I've picked the second one, which looks at checking for normality. So everything seems to be fine in this case. If it wasn't, then I maybe might want to go back and change how I'm adapting my model. So often what you'll do when you're fitting data in R is you might model the data one way, realize that there's some issues, and you maybe have to adjust to that. So if you can count for that, maybe you want to document that for other people. So the only other thing I'd say I didn't do in this was I haven't really written a lot. So all I can say is that's everything. Thanks for listening. I'll save this and I might want to preview the output here. And there you go. So I'm loading in things at the top. I'm loading in my data. It's showing me how I've made my plots and how I've filtered things out. And then I've got my little text at the end. Obviously, of course, you maybe want to document everything that you're doing here properly. So that's everything then. Thanks a lot for listening. If you have any extra questions, then I'm free via email, or if you get back to me during the one-to-one sessions, then I'll try and help as best I can. Thanks.